Hello everyone, this is an extension of the lecture on deformative prototyping and modeling. So I'm going to quickly go through some of the techniques that we captured during the lecture. Let's start with a simple planar surface. Let's copy this. So I'm just going to quickly go through again the rebuild command. The rebuild command allows you to introduce more control points to your surface, so that where it says here point count U is along one direction, which is similar to X. So U and V are used in situations where it's similar to X and Y, so that in case it's a curvilinear surface, then it's still referencing U as similar to X, and V would be the Y direction. And usually if it's got a third dimension, then it would be UVM, right? XY, it's really only for planar surfaces. But in this case, in case the surface is not planar, so it allows you to add more points. So let's leave it at 5, V 5. You can also change that if you want. Another important aspect of this command is the degree of curvature. So you can describe the different degrees. So let's test 1. So 1 degree of curvature looks like this. Let's turn on our points. Okay, so it allows you to, the points would allow you to select different areas of your model so that you'll be able to manipulate it. Okay, so this is what a 1 degree curvature looks like. Now, using the same command, if we change the degree of curvature, build, let's add 3, turn on your points. Okay, so that's the difference with describing the different types of the different degrees of your curvature. Okay, at this point, you still won't be able to 3D print this or develop this because it has no thickness. Just remember that. I'm sure most of you would know this already. So that it's a single surface, you'll be able to extrude it. So let's just do an extrude. Okay, so something like that, then you'll be able to 3D print it. And the other thing we went through regarding the this rebuild command would be on solids. The unique thing about a sphere, so we used the sphere during the lecture, is that even though it's a 3-dimensional object or geometry, it's still considered one surface, which means you'll be able to use the rebuild command just for the sphere, because the rebuild command won't work on a poly surface. But we're going to talk about a different technique shortly with using the rebuild command on a poly surface. So that with the sphere, you'll be able to use the rebuild. Yeah. Okay, I think we also demonstrated what happens when you don't have a degree of curvature, and if it's to a minimum of 1, then it becomes a more of a polyhedron. So it becomes like a, like a diamond. So in this case, we'll do a few different tests. 10 and 10, okay. And the one thing I think is helpful with using a primitive shape such as the sphere is that you can just develop your own logic in the way you manipulate. Let's turn on the points. In the way you manipulate your sphere so that you can turn it into an object that has real world values. So in this case, we're gonna create a simple bowl, right? Um, if you're not happy with that, you might want to capture more layers of, say, something like this. Okay, and kind of guides you as to how thin you'd want the edges, right? So in this case, if you as you can see, you'd still need to be able to manipulate these kind of hump areas here, so that you might want to capture that on its own. Okay, lower it, and you can keep adjusting it until you're happy with it, basically. And perhaps, oops, no, wait, don't need that. Zoom in a little bit more. Perhaps this. I think you need those as well. Okay, so something like that, right? So now it looks like a bowl. And you might also want to adjust the bottom bit so that you're not, it can be a little bit more stable if you were to flatten the bottom bit. All right, so with this bowl, you can adjust it until you're happy with it just by using the rebuild command. As well, we also demonstrated how you can change the shape of it so it doesn't have to be a bowl like this. But what I wanted to point out with using this is how you can quickly go from this. And perhaps the challenge is being able to fabricate it not just by 3D printing it, because surely you'll be able to 3D print this because it's a solid object. But if the challenge is using a laser cutter, okay, you need to find a way to discretize the surfaces of this curvilinear object, so that a way of doing that, so that you can actually laser cut the faces of an object and assemble it together, and it would look like a bowl, right? So if you're faced with that scenario, one way of doing it, which is an easy way. I'm not sure. I'm sure there are other methods out there, but this is what I do if I wanted to, create an object that's curvilinear or more organic in shape, and you want it to look like like an origami kind of object that's been put together. Then what I would do, let's turn off these points. What I would do would be try to discretize the surfaces, and one good method would be turning this into a mesh, because a mesh has that better ability to make sure the surfaces or the polygons are planar, obviously. So let's go mesh. Now this pop-up box would show you different components of the mesh. There are two things here that I look at. It's the minimum edge length and the maximum edge length. This figure describes how big or how small your polygons would be. So let's try a 5. Obviously, the lower it is, the more dense it would be, the smaller the polygons would be, and it would be more of a HD. So let's go 5 and test that. Okay, so now it's underneath this. So if you're looking for it, just drag the original one out. So that's your mesh. If you zoom in, you'll be able to see the the mesh faces. It's quite jagged, but that's how it's calculated, a similar kind of, you know, shape to your original design. So it's calculated how it can be. Still, you'll be able to, once you're happy with it. Now, what it's done is essentially calculated it so that each face of this mesh would be planar or close to planar, close to 1 degree of curvature. So I think for this exercise, let's just demonstrate using lower kind of polygon count on the mesh. So let's do that again. Mesh. Okay, so to make it less, I would just increase this to say 13 and 13 edge length. Okay. All right, so now we have something like this, that kind of close to, but similar to it, similar to scale and the look of the original bowl. So at this point, you'd probably be thinking you'd want to be able to laser cut those faces so that you can make it into a bowl or the shape that's close to your original design. One way of doing that, I know most of you would have used the unroll surface. Now, the unroll surface only works for NURBS geometry. So you won't be able to use it for this mesh because it's a different type of geometry. You'll be able to use it for a NURBS geometry like this. However, it would only work if the surfaces are planar. So if you were to select your original design, it allows you to select it, but it won't be able to calculate it. It says here, unrolling doubly curved surfaces will produce inaccurate results. So it's not doing it, basically. So this is the strategy in performing that same operation, but, you know, with a lower polygon count or faces so that they're all planar. So now you have this mesh. We can easily turn this mesh back into NURBS. So mesh to NURBS. Okay, so let's put it next to each other. So now it looks exactly the same. You have that mesh and you have this NURBS geometry that now you'll be able to use the unroll surface. Unroll surface. Okay, so it says here explode. You have a different other options here. Explode no. If you put yes, all the pieces will be scattered and not connected, interconnected. Labels no. You can also put labels yes if you wish, so you know how to assemble them together and so forth, and just enter. So there's your laser cutting piece for the same bowl. All right. And if you zoom in, just make sure that there are no overlapping surfaces on it. The more complex it is, there's a danger that some of your surfaces may be overlapping when it's unrolled. In that case, you'll need to kind of individually segregate them so that it's laid out correctly and properly. Okay, so now we know this piece can be laser cut and it can be put together like a bowl, like that. Okay, so that's the strategy for this. It's turning so from a single surface, we turned it into a 3D object, and the 3D object, we turn it into a mesh that calculates the planarity of the surfaces, and then turn it back into a NURBS geometry so that you can unroll it. Okay, so that's for that. That's solid. So again, I spoke about the rebuild command, that you won't be able to use it on a poly surface. So that worked on the sphere because it's only one surface. But if you were to use a cube, all right, so let's go cube. Okay, with the cube, and if you try the rebuild command, rebuild, it won't allow you to select it because it's not just a single surface, it's a poly surface. You can only rebuild a single surface. So the solution there would be to explode this cube, right? If you wanted to change that, explode, right? So now you're able to manipulate each of this surface, each of this, six-sided surface. Your design may not be a cube, it could be something more, complex. So let's do some tests so that if you were to select the top and rebuild that surface, let's put a lower number there, 5, 5, and degree 3, that's fine. Let's turn on the points so that what this does is that where you see the control points on the edges, it allows you to keep them intact so that it doesn't burst in the seams when you stretch it. So that if you were to select those points close to the edges like that, right, and if you were to manipulate it, as you can see, it keeps the seams together so that after you change its shape, you may want to join them together, join the surfaces together again to make it a poly surface. Okay, so that's just a note in that one. And again, rebuild, right? Remove the curvature, maybe make it 2. Turn on the points. Let's do some tests. Okay, so it's less curved, still quite dynamic, and as you can see, the points kind of keep it in place, keep certain parts of it in place so that it's still a solid object. You can still put it together and 3D print your final design. So, join. So now it becomes a poly surface again, right? So that's just a note on that one. Okay, so that's there. Mesh box. Okay, we also spoke about mesh and how to be able to, easily control and manipulate the shape of a mesh. Let's go mesh. If you look at the polygon mesh primitives, it allows you an initial kind of primitive shape that you'll be able to manipulate. Let's just try on a box. Let's create something with this. Now, when you create a box, by default, it just remembered what my last entry of this count. It says X count, Y count, Z count. So I always prefer to start off with 1 polygon count for each surface. Now you can change that. I think if you have a look at yours, by default it'll be 10. Right, by default, but it just remembered my last entry on this, so it'll be 1. So if you want to change it, you can. For this exercise, I'm just using 1. So I feel it's easier to manipulate the mesh if you're form finding or just creating a very specific type of object. So we're going to try to create a let's do an origami inspired building on this one. Okay. All right, so now if you select this mesh, it's a mesh, it's not a poly surface, so that if you look up here above the command line, it says 1 mesh added. It looks like a poly surface, but it's just single, single face meshes on each side. So the way to be able to select each of the elements that make up this mesh is you use the selection filter command, selection filter, another pop-up box that allows you to to select different elements of your geometries. For this it's a mesh. If you were to tick what it says here, sub-objects, okay, tick the sub-objects, more words come up. So points / vertices. Points basically refer to NURBS geometry. The vertices are for the mesh, similar to surfaces for the NURBS and faces for the mesh, and likewise curves for the NURBS geometry, and edges is a term used for a mesh. Okay, so if you were to turn it off, you won't be able to select those, but if you turn on sub objects, then you'll be able to select different parts of the mesh. So that these are the faces of your mesh, or single edges, or even the points of a mesh that you can manipulate. Okay, let's move this window aside, so the pop-up window. Okay, and make sure, look down below if your gumball is on. For this exercise, we're going to use gumball, right? And let's select this mesh. Now with the gumball, we spoke about if you were to use just the dragging operation of this, so if you were to drag the arrow, it simply stretches the object itself, right? But if you were to drag it using that little node along the arrow, what it does is it doesn't extrude it. It doesn't stretch it. What it does is essentially extrudes it, meaning it creates more polygons along the sides because it simply extrudes the surface itself. Okay, this surface that you've selected. So that would then allow you to manipulate it for this. Let's do again similarly. You can drag this kind of on plan view. You can drag it around and rotate it. Okay, let's rotate that. Another way, instead of just randomly dragging that point, you can type in. So click on the point and type in a figure 20. That's fine. Similarly for the rotation, you can put in a value there, plus 45. That's fine. And let's do a few of these. All right. And let's switch it around, minus 45. Okay. That 45. This, let's do a few of these. Minus 45. Okay. A couple more, I think. 45. Enter. Minus 45. Okay, so you could have something like this happening. As you can see, you've twisted the surfaces as you've extruded them. You can also adjust, select. You may want to select, for example, these parts here. Okay, let's try to select just the edges of these. Okay, and at this point you'd also be able to use the gumball to be able to stretch it. If you hold down the shift key, it stretches it in all directions, so it's quite uniform in the way you stretch it. Okay. Making it smaller and so forth. Okay, or you can still shift it around, move it around. Right. So what it's done is technically, as you've rotated it, each of the polygon of this structure, it's no longer planar. So when we initially created this mesh, this initial box down below is planar, which means you'll be able to develop it and laser cut this piece and that and so forth. But when you rotated it, essentially what it's done, it's no longer flat, so that it's now curvilinear in the surfaces are now curvilinear, and you won't be able to use laser cutting for this. So the solution for laser cutting something like this would be, again, we're going to discretize this form and find a way to, make them developable and make them flat. So one way of doing that is we use the triangulation technique. But first, let's copy this. Okay, just move it a little bit more. That's fine. Okay, so now we've got two of the same building. What we can do is let's look at it as well in elevation. It looks the same. Let's go to mesh and find a way to triangulate. This is what you need. Triangulate non-planar quads, meaning to say your quad surfaces or quad polygons will be calculated so that it would be cut up in a triangle, because a triangle or 3 points in 3D space are always coplanar, meaning any 3 points would create a plane. So that, again, another pop-up box, triangulate non-planar quads. There are different ways to triangulate it. Have a look at the split method drop-down menu. It says here shortest, diagonal, etc., etc. So let's try this shortest diagonal for this tower and triangulate. All right, so it's calculated it to a point. It's kind of changed the look of it if you look at it the perspective view. Now we're going to test the other method for triangulation for this other building. Mesh edit tools, triangulate non-planar quads. Select the mesh, enter. Oops. Okay. For the drop down, we're going to use the longest diagonal. Okay, and let's see the differences. Okay, already it's kind of produced a different result from the original one. Not easy to see on this perspective view. Let's change it to Arctic. Okay, now we see the differences on the way the mesh was triangulated. Okay, thank you very much. That ends the additional tutorial for the lecture. Thank you.